When you think of wildfires, you may think of destruction, skeletal forests, property loss, and lives forever changed. But fires can also bring rejuvenation. They can renew ecosystems, nourish the soil, and foster new growth. But climate change is causing these fires to burn larger, longer, and more often. These larger and more frequent fires damage ecosystems, disrupt communities, and can even influence the climate. So, understanding the basics of wildfires and how they're impacted by climate change is key to our ability to predict where and when fires are likely to occur, as well as remotely detect and track wildfires once they ignite, and ultimately mitigate their impacts on human health and the environment. This is Wildfires 101.
Words appear. Anatomy of a fire.
The first thing you should know is that wildfires require 3 key ingredients: fuel to burn, the right conditions, and a source of ignition. But what does that actually mean? So fuel, like needles, leaves, or wood on the forest floor, is rarely a fire's limiting factor. And the conditions that are favorable for fire, like hot, dry, and windy days, are becoming more and more common as our climate changes. Under these fire weather conditions, fuels dry out and become more susceptible to burn. As for a source of ignition, well, most of the wildfires that NASA detects from space are started by people. Others, usually in the Arctic and boreal regions, are ignited by lightning strikes. NASA can track these conditions and inform land managers when an area appears prone to wildfire.
Eyes in space.
Every day, NASA is able to detect thousands of new fires from space. Along with our partners at NOAA, we use both polar orbiting and geostationary satellites to get insight as to the structure and evolution of a fire. Geostationary satellites remain fixed in relationship to the globe, giving us new images of one hemisphere every 5 to 15 minutes. However, the resolution is usually coarser than that of polar orbiting satellites, which will pass over a fire twice per day. From over 500 miles above the Earth, these orbiting satellites will detect and characterize thermal anomalies, locations on the Earth's surface that are hotter than their neighbors that can indicate burning associated with new or existing fire events. Importantly, these instruments can detect fires at night, a time when wildfires typically lay down and smolder. Since the majority of large wildfires last for multiple days, the ability to track them both day and night is instrumental to helping land managers combat the blazes.
Fires rage.
But it's not just the fire itself that's dangerous. Wildfire smoke can travel for thousands of miles, having the ability to blanket large swaths of a continent from a single wildfire. Smoke from wildfires can reach high altitudes, between 3 to 6 miles, and travel with prevailing winds. This smoke can linger in the air for several weeks, changing the chemistry of the atmosphere and reducing the amount of sunlight reaching the surface. Smoke that gets trapped near the ground severely impacts the air quality in surrounding communities. And poor air quality can last for months as large fires continue to smolder even after the fire itself has been contained.
Lasting impacts.
Climate change is not only impacting the size and intensity of wildfires, but also their frequency in some regions. NASA has over 22 years of daily fire data to track wildfire trends. This is important to get a sense of how fire regimes, the historical frequency of wildfires in a region, are changing over time. Understanding an ecosystem's fire regime is important because in many instances, wildfire is essential to maintain a mixture of younger and older vegetation. However, when fires occur too frequently or with increased severity, it can have devastating effects like destroying habitat, changing soil chemistry, and clogging waterways. Not to mention releasing greenhouse gases like CO2 and aerosols into the atmosphere. NASA can study wildfire's impact on the landscape by measuring burn scars, as well as tracking vegetation loss and rate of regrowth. Having an accurate assessment of a landscape post-fire is a key part of understanding how ecosystems recover over time. NASA's ability to not only track wildfires, but also the conditions that lead to them, is essential to our ability to mitigate their impacts. We're working with land managers and those on the front lines to give them the tools, including near real-time data, to help them make decisions to minimize the risks and plan for the future.
Logo, NASA. Accessibility provided by the U.S. Department of Education.